I'm going to take a two-dimensional region in the XY plane and rotate it about the Y-axis and find the volume after that object has been rotated around and created a three-dimensional object. The region that I'm going to be working with is bounded by y equals 2x, y equals 10, and x equals 0. This is y equals 2x, y equals 10, x equals 0. So the region I'm working with is shaded there. When I rotate that about the y-axis, I'm going to get a cone. So when you rotate that, when you swing it around, it does something like this. So I've got this three-dimensional cone, and I want to find the volume of that thing. The easiest way to do that with an integral is to slice the object up using the disk method. So I want to slice it into horizontal pieces that build up from bottom to top or top to bottom. Any one of those slices that I pick will look something like this. And I'm going to call the width of that thing, or the height, delta y. It's in the y direction, and it changes depending on how many slices I'm taking. But the idea is I'm creating a bunch of these from the bottom up to the top. That gives me an approximation of the volume. If I want the exact volume, I take the limit of that sum of volumes as this delta y is shrinking down to 0. So before I take the limit, the approximation of the volume is just adding up the volumes of all these disks. And the volume of a disk is the area of the base, so the area of the circle, times the height delta y. So it's pi r squared times y times delta y, where r, the radius, goes from the y-axis out to this line y equals 2x. And it's the x value there. So that radius, I know it's the x value, so this is really pi x squared times delta y, but I'm going to be integrating with respect to y. So I want to give x as a function of y here. On the line y equals 2x, if I solve for x, that's just y over 2. So when I take the limit as delta y goes to 0 to get the exact volume, I get the integral of pi times y over 2 squared, and then delta y turns into dy. And I need these slabs, these disks, to go from y equals 0 all the way up to y equals 10. So those are my bounds. Now I'm ready to find the antiderivative. I need to think of this term as y squared over 4. After you multiply y over 2 times y over 2, you get this. So I'm going to keep this pi over 4 out in front. And then the antiderivative of y squared is y cubed over 3. You go from 0 to 10. I want to simplify this. So this is going to give me 1,000 pi on top and then 12 on the bottom. But 1,000 divided by 4 is 250. So this will be 250 pi over 3. That's the volume of this purple cone.